today we're announcing our next generation, the RTX Blackwell family. Here it is, our brand new GeForce RTX 50 series Blackwell architecture. The GPU is just a beast. 92 billion transistors, 4,000 TOPS, 4 petaflops of AI, 3 times higher than the last generation Ada, 380 ray tracing teraflops, so that we could, for the pixels that we have to compute the most beautiful image you possibly can. And of course, 125 shader teraflops. There's actually 2 dual shaders. One is for floating point, one is for integer. G7 memory from Micron, 1.8 terabytes per second, twice the performance of our last generation. And we now have the ability to intermix AI workloads with computer graphics workloads. And one of the amazing things about this generation is the programmable shader is also able to now process neural networks. Even the mechanical design is a miracle. Look at this, it's got 2 fans. This whole graphics card is just one giant fan. You know, so the question is, where's the graphics card? It's literally this big. The voltage regulator design is state-of-the-art, incredible design. The engineering team did a great job. Okay, so those are the speeds and feeds, so how does it compare? Well, this is RTX 4090. I know many of you have one. Well, now with the Blackwell family, RTX 5070, 4090 performance at 549. Impossible without artificial intelligence. Impossible without the G7 memories. Okay, so 5070, 4090 performance, $549, and here's the whole family. Starting from 5070 all the way up to 5090. 5090, twice the performance of a 4090. Of course, we're producing at very large scale availability starting January. Machine learning has changed how every application is going to be built, how computing will be done, and the possibilities beyond. In a lot of ways, all of this with AI is the house that GeForce built. GeForce enabled AI to reach the masses. And now, AI is coming home to GeForce. There are so many things that you can't do without AI. No computer graphics researcher, no computer scientist would have told you that it is possible for us to ray trace every single pixel at this point. Ray tracing is a simulation of light. The amount of geometry that you saw was absolutely insane. It would have been impossible without artificial intelligence. There are 2 fundamental things that we did. We used, of course, programmable shading and ray traced acceleration to produce incredibly beautiful pixels. But then we have artificial intelligence be conditioned, be controlled by that pixel to generate a whole bunch of other pixels. Not only is it able to generate other pixels spatially, because it's aware of what the color should be, it has been trained on a supercomputer back in NVIDIA, and so the neural network that's running on the GPU can infer and predict the pixels that we did not render. Not only can we do that, it's called DLSS. The latest generation of DLSS also generates beyond frames. It can predict the future, generating 3 additional frames for every frame that we calculate. What you saw, if we just said 4 frames of what you saw, because we're going to render 1 frame and generate 3. If I said 4 frames at full HD, 4K, that's 33 million pixels or so. Out of that 33 million pixels, we computed only 2. It is an absolute miracle that we can computationally using programmable shaders and our ray tracing engine, to compute 2 million pixels and have AI predict all of the other 33. And as a result, we're able to render at incredibly high performance because AI does a lot less computation. It takes, of course, an enormous amount of training to produce that, but once you train it, the generation is extremely efficient. So this is one of the incredible capabilities of artificial intelligence, and that's why there's so many amazing things that are happening. We used GeForce to enable artificial intelligence, and now artificial intelligence is revolutionizing GeForce. Well, it is incredible, but we managed to put these in gigantic performance GPUs into a laptop. This is a 5070 laptop. For $1299, this 5070 laptop has a 4090 performance. So can you imagine? You get this incredible graphics card here, Blackwell. We're going to shrink it and put it in there. Does that make any sense? Well, you can't do that without artificial intelligence. And the reason for that is because we're generating most of the pixels using our tensor cores. So we ray trace only the pixels we need, and we generate, using artificial intelligence, all of the other pixels we have. As a result, the energy efficiency is just off the charts. The future of computer graphics is neural rendering, the fusion of artificial intelligence and computer graphics. What's really amazing is the family of GPUs we're going to put in here. And so the 5090 will fit into a laptop, a thin laptop. That last laptop was 14.9 millimeters. You got a 5080, 5070 Ti, and 5070. Okay? So, ladies and gentlemen, the RTX Blackwell family. Well, GeForce democratized AI. Now AI has come back and revolutionized GeForce. Let's talk about artificial intelligence. Well, Blackwell is in full production. It is incredible what it looks like. So first of all, every single cloud service provider now have systems up and running. 200 different configurations. They're liquid-cooled, air-cooled, x86, NVIDIA Grace CPU versions, NVLink 36 by 2, NVLink 72 by 1, whole bunch of different types of systems so that we can accommodate just about every single data center in the world. These systems are being currently manufactured in some 45 factories. It tells you how pervasive artificial intelligence is and how much the industry is jumping onto artificial intelligence in this new computing model. Well, the reason why we're driving it so hard is because we need a lot more computation. And it's very clear, it's hard to tell. You don't ever want to reach your hands into a dark place. Hang on a second, is this a good idea? All right. This is my show and tell. This is a show and tell. So, this NVLink system, this right here, this NVLink system, this is GB200 NVLink 72. It is 1.5 tons, 600,000 parts, approximately equal to 20 cars, 120 kilowatts. It has a spine behind it that connects all of these GPU together, 2 miles of copper cable. We build them, we liquid cool them, we test them, we disassemble them, ship them in parts to the data centers because it's 1.5 tons. We reassemble it outside the data centers and install them. The manufacturing is insane. But the goal of all of this is because the scaling laws are driving computing so hard that this level of computation, Blackwell over our last generation, improves the performance per watt by a factor of 4. Performance per watt by a factor of 4, performance per dollar by a factor of 3. That basically says that in one generation, we reduce the cost of training these models by a factor of 3. Or if you want to increase the size of your model by a factor of 3, it's about the same cost. And every single data center is limited by power. And so if the perf per watt of Blackwell is 4 times our last generation, then the revenue that could be generated, the amount of business that can be generated in the data center is increased by a factor of 4. Now, the goal of all of this is so that we can create one giant chip. The amount of computation we need is really quite incredible. And this is basically one giant chip. If we had to build this as one chip, obviously this would be the size of the wafer, but this doesn't include the impact of yield. It would have to be probably 3 or 4 times this size. But what we basically have here is 72 Blackwell GPUs or 144 dies. This one chip here is 1.4 exaflops. The world's largest supercomputer, fastest supercomputer, only recently, this entire room's supercomputer only recently achieved an exaflop plus. This is 1.4 exaflops of AI floating point performance. It has 14 terabytes of memory, but here's the amazing thing. The memory bandwidth is 1.2 petabytes per second. That's basically the entire internet traffic that's happening right now. The entire world's internet traffic is being processed across these chips. This is what we're trying to do, and this is the miracle. This is the miracle of the Blackwell system. The Blackwell dies right here. It is the largest single chip the world's ever made. But yet, the miracle is really, in addition to that, this is the Grace Blackwell system. Okay, let's talk about physical AI. What we need to do is we need to create the effectively the world model as opposed to GPT, which is a language model. And this world model has to understand the language of the world. It has to understand physical dynamics, things like gravity and friction and inertia. It has to understand cause and effect. If you drop something, it falls to the ground. And so all of these types of understanding is intuitive understanding that we know that most models today have a very hard time with. And so we would like to create a world, we need a world foundation model. Today we're announcing a very big thing. We're announcing NVIDIA Cosmos, a world foundation model that is designed, that was created to understand the physical world. And the only way for you to really understand this is to see it. NVIDIA Cosmos, the world's first world foundation model. It is trained on 20 million hours of video. The 20 million hours of video focuses on physical dynamic things. So it's really about teaching the AI, not about generating creative content, but teaching the AI to understand the physical world. And from this, with this physical AI, there are many downstream things that we could do as a result. We could do synthetic data generation to train models. We could distill it and turn it into effectively the beginnings of a robotics model. You could have it generate multiple physically based, physically plausible scenarios of the future, basically do a Doctor Strange. And today we're announcing that Cosmos is open licensed. It's open and available on GitHub. The magic happens when you connect Cosmos to Omniverse. And the reason fundamentally is this. Omniverse is a physics grounded, not physically grounded, but physics grounded. It's a simulator. When you connect that to Cosmos, it provides the grounding, the ground truth that can control and to condition the Osmos generation. As a result, what comes out of Osmos is grounded on truth. This is exactly the same idea as connecting a large language model to a RAG, to a retrieval augmented generation system. You want to ground the AI generation on ground truth. And so the combination of the two gives you a physically simulated, a physically grounded multiverse generator. Omniverse plus Cosmos represents the third computer that's necessary for building robotic systems. Every robotics company will ultimately have to build 3 computers. One computer, of course, to train the AI. We call it the DGX computer to train the AI. Another, of course, when you're done, to deploy the AI. We call that AGX. That's inside the car, in the robot, or in an AMR, or, these computers are at the edge and they're autonomous. But to connect the two, you need a digital twin. And this is all the simulations that you were seeing. The digital twin is where the AI that has been trained goes to practice, to be refined, to do its synthetic data generation. And so it's the digital twin of the AI. These 3 computers are going to be working interactively. NVIDIA's strategy for the industrial world, and we've been talking about this for some time, is this 3-computer system. instead of a three-body problem, we have a three-computer solution. There are millions of factories, hundreds of thousands of warehouses. That's basically is the backbone of a $50 trillion manufacturing industry. All of that has to become software-defined. All of it has to have automation in the future. And all of it will be infused with robotics. And the reason for that is very clear. Everybody wants to digitalize the future of industries. There's so much waste, so much opportunity for automation in that $50 trillion of the world's GDP. Every factory will have a digital twin. And that digital twin operates exactly like the real factory. And in fact, you could use Omniverse with Cosmos to generate a whole bunch of future scenarios, and then an AI decides which one of the scenarios are the most optimal for whatever KPIs, and that becomes the programming constraints, the program, if you will, the AIs that will be deployed into the real factories. The next example, autonomous vehicles. The AV revolution has arrived. After so many years, with Waymo's success and Tesla's success, it is very, very clear autonomous vehicles has finally arrived. Well, our offering to this industry is the three computers: the training systems to train the AIs, the simulation systems, and the synthetic data generation systems, Omniverse and now Cosmos, and also the computer that's inside the car. Each car company might work with us in a different way, use one or two or three of the computers. We're working with just about every major car company around the world: Waymo and Zoox and Tesla, of course, in their data center, BYD, the largest EV company in the world. JLR's got a really cool car coming. Mercedes has a fleet of cars coming with NVIDIA starting this year, going to production. And I'm super, super pleased to announce that today, Toyota and NVIDIA are going to partner together to create their next generation AVs. 100 million cars built each year, a billion vehicles on the road all over the world, 1 trillion miles that are driven around the world each year. And so this is going to be a very large industry. I predict that this will likely be the first multi-trillion-dollar robotics industry. Just a few of these cars that are starting to ramp into the world. Our business is already $4 billion, and this year, probably on a run rate about $5 billion. So really significant business already. This is going to be very large. Well, today we're announcing that our next generation processor for the car, our next generation computer for the car, is called Thor. I have one right here. Hang on a second. This is Thor. This is a robotics computer. This is a robotics computer. It takes sensors and just a madness amount of sensor information. Umpteen cameras, high resolution, radars, lidars, they're all coming into this chip. And this chip has to process all that sensor, turn them into tokens, put them into a transformer, and predict the next path. And this AV computer is now in full production. Thor is 20 times the processing capability of our last generation Orin, which is really the standard of autonomous vehicles today. And so this is just really quite incredible. Thor is in full production. This robotics processor, by the way, also goes into a full robot. And so it could be an AMR, it could be a brain, it could be the manipulator. This processor basically is a universal robotics computer. But I want to show you how we use the car to reconstruct digital twins automatically using AI and use that capability to train future AI models. We are going to have mountains of training data for autonomous vehicles. Of course, we still need actual cars on the road. Of course, we will continuously collect data for as long as we shall live. However, synthetic data generation using this multiverse, physically based, physically grounded capability so that we generate data for training AIs that are physically grounded and accurate or plausible so that we could have an enormous amount of data to train with. The AV industry is here. The ChatGPT moment for general robotics is just around the corner. And in fact, all of the enabling technologies that I've been talking about is going to make it possible for us in the next several years to see very rapid breakthroughs, surprising breakthroughs in general robotics. Now, the reason why general robotics is so important, if we could possibly build these amazing robots, we could deploy them in exactly the world that we've built for ourselves. These three robots are, one, agentic robots, and agentic AI, because they're information workers. So long as they could accommodate the computers that we have in our offices, it's going to be great. Number two, self-driving cars. And the reason for that is we spent 100+ years building roads and cities. And then number three, humanoid robots. If we have the technology to solve these three, this will be the largest technology industry the world's ever seen. And so we think that the robotics era is just around the corner. The critical capability is how to train these robots. In the case of humanoid robots, the imitation information is rather hard to collect. And the reason for that is, in the case of car, you just drive it. We're driving cars all the time. In the case of these humanoid robots, the imitation information, the human demonstration is rather laborious to do. And so we need to come up with a clever way to take hundreds of demonstrations, thousands of human demonstrations, and somehow use artificial intelligence and omniverse to synthetically generate millions of synthetically generated motions. And from those motions, the AI can learn how to perform a task. NVIDIA Isaac Group. NVIDIA Isaac Group. This is our platform to provide technology elements to the robotics industry to accelerate the development of general robotics. And, well, none of this would be possible if not for this incredible project that we started about a decade ago. Inside the company was called Project Digits, Deep Learning GPU Intelligence Training System. Digits. Well, before we launched it, I shrunk it to DGX, and to harmonize it with RTX, AGX, OVX, and all of the other X's that we have in the company. The reason why we built it was because we wanted to make it possible for researchers and startups to have an out-of-the-box AI supercomputer. Imagine the way supercomputers were built in the past. You really have to build your own facility, and you have to go build your own infrastructure and really engineer it into existence. And so we created a supercomputer for AI development for researchers and startups that comes literally one out of the box. I delivered the first one to a startup company in 2016 called OpenAI, and Elon was there, and Ilya Sutskever was there, and many of the NVIDIA engineers were there, and we celebrated the arrival of DGX-1, and obviously it revolutionized artificial intelligence and computing. But now artificial intelligence is everywhere. It's not just in researchers and startup labs. We want artificial intelligence, as I mentioned in the beginning of our talk. This is now the new way of doing computing. This is the new way of doing software. Every software engineer, every creative artist, everybody who uses computers today as a tool will need an AI supercomputer. And so I just wish that DGX-1 was smaller. And, this is NVIDIA's latest AI supercomputer. And it's finally called Project Digits right now. And if you have a good name for it, reach out to us. Here's the amazing thing. This is an AI supercomputer. It runs the entire NVIDIA AI stack. All of NVIDIA software runs on this. DGX Cloud runs on this. It's even a workstation if you like it to be. And it's based on a super secret chip that we've been working on called GB110, the smallest Grace Blackwell that we make. And I have, well, you know what? Let's show everybody inside. It's just so cute. And this is the chip that's inside. This top secret chip we did in collaboration. The CPU, the Gray CPU, is built for NVIDIA in collaboration with MediaTek. They're the world's leading SoC company, and they worked with us to build this CPU SoC, and connect it with chip-to-chip NVLink to the Blackwell GPU. This little thing here is in full production. We're expecting this computer to be available around May timeframe. And it has nickel, GPU Direct, all of that out of the box. It's like a supercomputer. Our entire supercomputing stack is available. And so, NVIDIA Project Digits. Let me tell you what I told you. I told you that we are in production with 3 new Blackwells. Not only is the Grace Blackwell supercomputers, NVLink 72s, in production all over the world, we now have 3 new Blackwell systems in production. One amazing AI foundational world foundation model, the world's first physical AI foundation model. It's open, available to activate the world's industries of robotics and such. And three robots working on agentic AI, humanoid robots, and self-driving cars. It's been an incredible year. I want to thank all of you for your partnership. Thank all of you for coming. Have a great CES, everybody! Happy New Year! Thank you.